So here's our review for Chapter 7 test. There'll be one problem where you have to find the area between curves. So this is section 7.1. It's pretty straightforward. I'll give you two equations, and you'll see a plot of the two functions. Let's say something like this. And so to find the area between the curves, first you have to recognize which curve is on the top, which curve is on the bottom, and you should be able to tell by just the form of the equations. And what we're looking for is the area between the curves, so it's this area here. So you need to find the, this one has where you have to find the points of intersection. So to do that, you're going to have, y equals some function of x, and you'll have some y equals some function of g. And what you do is just set these equal to each other. And then you'll move everything to one side. It'll be some kind of quadratic equation. So I'm just writing in a generalized quadratic equation. So this is going to have some terms, and this will have some terms, and you combine them together and move them all to one side, and then you'll factor them. So you factor it using either, you can do it digitally, or you can use completing the square. You could use quadratic formula. So once you have, you have x minus something, let's just call it x1 and x minus x2, and of course the points of intersection, or whatever these, when you set each of the factors equal to 0 and solve for x, you'll get those two. So this will be x sub 1, this will be x sub 2, and then all you have to do is to find the area. You don't have pi or anything because you're not rotating anything, but you'd integrate from x1 to x2 whenever you came out with the limits here at the intersection, and you take this function that's on the top, which is this one right here, and you subtract that, and you multiply by dx, and then you carry out the subtraction process and simplify this down to a single polynomial, and then you integrate it, which is not a big deal. Stick in your limits and get an answer. Okay, so that's one. Just look. The other 4 problems, there's actually 6 problems. There's 5 regular, and there's 1 extra credit if anybody wants to try that. One of the 5 regular is the area. So the other 4 regular problems are either going to be disk, washer, shell, and then those can either be around the x-axis, the y-axis, y equals some number, I'll say y equals a, or x equals b. You can have another horizontal axis, or you can have another vertical axis. Now most of them will be either the x or y axis, but there will be one question regarding when the axis is something other than the x or y axis. So you just have to remember how to do that. You are getting to bring that. You do get to bring in that sheet with all the different possibilities, but for that to be useful, you've got to understand what's involved in it. And so there'll be a reasonably simple one that most everybody should get. It will be just a simple shape defined by the boundaries, the x-axis and the y-axis in a straight line. And for all of the problems, you're going to want to draw what we've been calling this representative rectangle. So in this case, if I were rotating around the x-axis and I was using the disk method, then this would be my representative rectangle. And that would mean that I integrate with respect to x, because I would stack the rectangles up in this direction. And the function that defines the outer radius is a function of x. Now if I likewise ask you to integrate, rotate around the y-axis, then your rectangle would be this way for the disk method. And in that case, you'd be integrating with respect to y. So I'm integrating around the y, rotating around the y-axis, so I've got a disk. And the outside radius is this distance, and that has to be a function of y. So this linear equation, normally you would be given something like, something like that. So if you're rotating around the y-axis with a disk, you have to solve this equation for x, and that's what you get. If you move that to this side, it becomes positive. You move that to that side, it becomes negative. So, you have all the equations. This is the disk method around the y-axis. You just need to know what r of y is. The volume is equal to, if you're going around the y-axis, it's going to be pi times the integral from c to d, which is the x limits, y limits of integration, times r of y squared dy. And if you had a vertical rectangle, then you would integrate from a to b in the x direction. So there'll be something reasonably simple like that. There'll be a more complicated area. We did, one in class. It's not going to be this one, but I'm going to use this as just a demonstration. We had something like a curve that looked like this, and then we had a curve that looked like maybe downward like that. And so you'll have to make some decision relative to, is the disk method the better idea, or is the shell method, disk or washer method or the shell method? So make sure you understand those decision-making points. So the way you do that is you create a rectangle and you look at what's the situation depending upon the orientation of the rectangle. In this case, as I move this rectangle, it gets smaller and smaller and smaller. As I move to the left, as I move to the right, the upper curve is always the same function, and the lower curve is always the same function, which is good. So that looks encouraging. Now if I did it the other way, you'll notice that in this case, this function, this would be plus the square root of something, this would be minus the square root of something. I'd have to change my limits at this point because I have a change from one function to another function. So this would not be the way to go. If I had to choose between vertical or horizontal rectangles, I would pick vertical rectangles. So once you determine which makes the most sense, then you know you're going to integrate with respect to x. In this case, if I go around the y-axis, I'm going to have a shell, because these rectangles are going to loop around the y-axis, and the shell is going to be this. This is going to be h of x, the distance from here to here. So let's say this is f, some function f of x, and this is some function g of x. And because we're integrating with respect to x, and we're integrating around the y-axis, in this case the volume would be equal to 2 pi the integral from a to b, where this would be x equals a, and this would be x equals b. And because it's around the y-axis, it's a shell, so I have t of x times h of x times dx. So you get 2 pi integral from a to b, whatever those points of intersection are. P of x is x, and that's the case for any time you're integrating, you're rotating around the shell around an axis. And then h of x is going to be f of x minus g of x, kind of like the area. You just take the difference between the two in the shell method. So the height of these rectangles is just the value of this function minus the value of that function. So that's around the y-axis. Now, as an example, if I were to ask to rotate it around that axis instead of, that's a different vertical axis. We'll say that's y x equals c. It's going to be x equals something. So let's say that's x equals c. So when you're rotating around the y-axis, this is the radius of the shell, which is x. And when you're rotating around this one, it's the other way around. You're coming from here to here. So remember, this is c. The other direction is x. So if you were to find the volume rotating around the line, the vertical line, x equals c, then the function would be very similar. It's still integrate from a to b because that's the limits of where the area is. But instead of x, it's going to be c minus x. And then you still have the same distance between the two ends of the rectangle. So that part stays the same. So if this were c equals 10, then it would be 10 minus x. And that's how it works with the shell method. You always, the only thing that really changes when you change the axis of rotation is this first term. And it's whatever the axis is. And you can see if c were equal to 0, yeah, just thinking if c equals 0, what does that mean as far as this thing? Because you get a negative sign, which is what's bothering me when I mention that. So you'd have to actually do so. If I had my axis of rotation here, then it would be different. This is if it's on one side. We've never really talked about what was on the other side, but if I took this and I moved it over here, so it's still vertical, but it's here, then you can see that the radius is this distance. So let's call this x equals d, just to demonstrate. So if you went around a vertical line, so you can't just arbitrarily use this formula. You'd have to think about what you're really doing. So this distance is d. This distance from here to here is x. So this is going to be x minus d. So there you would have 2 pi times the integral from a to b of x minus d. Again, you'd still have this same two functions that define the upper and lower boundaries of the width of the shell. Anyway, those are the kind of the options. If it's a vertical axis where the vertical axis is the y-axis, then you just use x. If the vertical axis is to the right of the area, then you use that x value minus c. If it was between the y-axis and this area, then you would do the other way around. And really, you also, I'm going to ask you to, if you're going to have to do this calculation, you have to show what these distances mean. So you got x, you got a vertical line x equals c, and then this distance here would be c minus x. If this is x, then x plus c minus x is c. Okay. There will be a problem on there like the one we had for homework, where you're going to have 3 intersecting lines. So it may be slightly simpler than one of these, may be a vertical or horizontal line, just to make it easier. But just think about that. If you made this horizontal, how might one way be better than the other? If I made this one vertical, how would there be one way that would be preferred over another way? Okay, let me see if there's anything else I want to tell you. And the key thing is to be able to understand the problems I gave you for homework. Yeah, so there'll be a shell method, there'll be a disk method, there'll be a washer method, there'll be a case where the axis of rotation is something other than either the x or the y-axis. And that's about it. So I'm not going to really, there are so many different options that if I was too specific, then I would be saying, I'm going to give you this exact problem. So I can't really do that. You just have to understand the procedures as far as choosing. Either I tell you what to do, or you have to decide what to do as far as the kind of method. And you have to be able to visualize what you're creating, a washer, a disk, or a shell, what those really mean, to fully understand what's going on. Okay. So I think that's all I'm going to tell you. If there was one thing that I would recommend that you watch, if you're only going to watch one thing, which hopefully you're not going to just watch one thing, is that video that I had the snow day. And let me just show you exactly which one that was. It came with the handout that had